All right, let's find some more Q values here, right? So again, I always like to write out the equation. This format for a reaction doesn't really do much for me, so I'm going to write 6,3 lithium 6, right? Bombarded by a neutron, right? A 1,0 neutron turns into an alpha particle, which is 4,2. And then the resulting nucleus is tritium, right? So this is an alpha particle, right? And for that, by the way, we're going to look up helium-4 for that mass there. And then let's see. And then this is plus 3,1 hydrogen. That's going to be tritium, right? That's this guy. Okay, so our nuclei are here. And then lithium 6 is there. Okay, and then our neutral, our neutron mass, our neutral neutron mass is 1.008665. Okay, so on the left side, our mass is lithium 6, so 6.015122 plus then this neutron here. Okay, becomes, and then we're going to look up helium-4, which is, you're probably going to memorize helium because it's like, we use it for alpha particles too. And then tritium is 3.016049. Okay, so notice if you're doing this right, that on this side we had 3 electrons, right? On this side, we also have 3 electrons accounted for in this mass that we're looking up. That's the neutral atom mass, okay? The only time you ever have to fudge that is, I think, some kind of beta decays, right? I can't remember, I think beta minus or beta plus. But anyway, let's take a look at this. Our mass, total mass on this side is 6.015122. plus 1.008665. And the total mass on this side is 7.023787. And then let's look at the total mass on this side, 4.002603 plus 3.016049. And we've got 7.018652. Right, so notice that the mass is going down. If I subtract this, right, if I go that guy minus this guy, I get a change in mass. Is that the mass goes down by 0.005135. Okay, and that's atomic mass units, right? So then the question is, where did that mass go? And the answer is that, of course, it turned into energy, right? So it's this plus energy, right? Kinetic energy. These things would have kinetic energy. Now, what's interesting is that this is the rest mass of these things that is sitting still. They would, if you massed them, if you could somehow measure their mass while they're moving it, really fast, they would actually have the same mass. You'd have exactly this total mass, and that's because these things would gain mass as they move. This is just special relativity, right? But we're talking about, the rest mass here. All right, wait, totally didn't need to do that. Okay, so times 931.5. And I have that 4.783 MeV. MeV is released. Now this is a positive Q value. Even though there's like a negative number there, we kind of ignore that because the reason it's negative is that mass is lost and that mass goes to energy. Okay, where did it go? It went to energy. If it gains mass, you ask the question, where did it come from? And you always do that twice, right? Where did it come from? Where did it go? Where did it come from? Right? Okay, anyway, sorry. It's snowing outside. All right, okay, hold on. Where are we? Did we answer the question? We did. Okay, so yeah, so this, we would call this exoergic. Okay, the fact that the Q value is positive means that it gives off energy. Q value is how much energy is given off. So if you give off negative energy, that means it requires energy, okay? We're going to have a endoergic one next here, okay? All right, wow, are we still recording?